So welcome back. We're going to do a strange lesson this evening. We're going to do something referred to as complex fractions. A complex fraction, you're going to see stuff like this. Basically what you have is fractions over a fraction. So you have this fraction bar and then another fraction bar. When you see stuff like that, we kind of call these complex fractions. So that's how the numerator is not a fraction, but notice how that denominator is actually a fraction. So that creates what we call a complicated fraction, or complex fraction. So again, notice how you have a fraction and not a fraction. But you can actually have fractions over fractions. Well, our examples will build. You'll see more complicated ones than these. Right now, notice how we're just dealing with numbers. So if this is just a basic problem, you know how the numerator can actually be simplified using order of operations, because we know that 1/4 plus 5/4 is 6/4. So I actually could just do that, and then we have divided by 4 still. And we do know what 6/4 reduces on down to 3/2, so I could change that to 3 over 2 divided by 4. So that would equal that. And we know there's another way to write a division symbol. We can also use that little dot dot with a little dash. So another way to look at this is to say, hey, that's 3/2 divided by 4. Remember, when you're dividing fractions, we can kind of make this look like a fraction. And we can kind of what we call Kentucky chicken fried, keep, change, and flip. So we keep the 3/2 as it is. We can change the multiplication. We can change the division multiplication as long as we flip that second number to 1/4. And then we learn to multiply fractions. You just multiply straight across, and you get 3/8. And that would be our way to do that problem. So you can actually simplify the numerator down to 3/2, and then do your division. Kind of a stranger way to do this problem is, one of the things is if you identify the denominators, notice that these 4s are really your only crazy complex fractions denominators. The bottom is really not a complex fraction. But what I can do is, using the LCD, which in this case 4 is really the only denominator, what I can do is multiply each side multiply the top and bottom by 4. So remember, when you have a 4 over 4, that's like multiplying by 1. So I'm not really changing the value of it because I'm multiplying by 1, but I can simplify it a little bit differently, because remember, I can actually distribute this 4 through the parentheses. So this 4 is actually going to divide out with this 4. So since 4 goes to 4 one time, and 1 times 1 is 1, that just becomes a 1. And again, 4 goes in 4, because remember, multiplying with the distributive property, these go together. 4 goes in 4 one time. 1 times 5 is 5. On the bottom, we just have 4 times 4, which is 16. So I can actually change this fraction into 6/16. And then notice how those numbers are even. I can divide those both by 2. And 2 goes into 6 3 times, and 2 goes into 16 8 times, and I would have then 3/8. And so notice how we do get the same answer, just doing a little bit different strategy. So when it comes to this problem right here, what I want to do is, instead of doing it like this, well, actually, let's go ahead and do it like this. Notice if I'm doing it like this, I have to get that common denominator at the bottom. So between a 2 and a 3, my common denominator, remember, we have to do those multiples. So your multiples of 2 are 2, 4, 6, 8, 10. Multiples of 3 are like 3, 6, 9, 12, 15. And we do see that there's a 6 in common. So notice how I can just leave the top alone. But I can change these bottom fractions so that they have 6's here. So I can change these denominators to 6's by getting a common denominator. Notice I had to multiply this by 3, which means I've got to multiply that by 3. That's going to change it to 9/6. Minus then, I had to multiply that by 2, which means I've got to multiply the top by 2. That's going to change it to 8/6. So as we play this out, the 2 stays on the top. But 9/6 take away 8/6 is going to be 1/6. And remember, we can write this as 2 divided by 1/6. Or in other words, 2 over 1 divided by 1/6. And we learned that we just kind of keep 2 over 1, change division to multiplication, and flip over to 6 over 1. And therefore, we end up with just 12. Or 12 over 1, which is 12 over 1 turns into 12. So this actually just simplifies down to a 12. Now, using the other concept is, if I can identify the denominator, notice the top one doesn't have a denominator, but the bottom does have a common denominator. It's that 6. So what I want to do is multiply the top and bottom by that 6. So I'm going to multiply the top by 6, and now I'm going to multiply the bottom by 6. Well, the top turns into a 12. 2 times 6 is 12. But when you do the bottom, you got to kind of use that distributive property here. So notice how 2 goes into 6 3 times. 3 times 3 is 9. 3 goes to 6 twice. 2 times 4 is 8. 9 minus 8 is 1. So therefore, that answer turns into a 12. So this is the pathway we want to try to work on, is multiplying the top and bottom of that complex fraction by that common denominator. Let's see where that math takes us. So again, you're probably not going to see a lot of that in the real world, but I've seen some of this can kind of fall into electricity. So as you look through this, you may see some formulas that involve electricity. This actually can play into that pathway of some of your science fields. Stay tuned.